when you're starting linear algebra, the most basic thing you gotta understand are systems of linear equations, because eventually we're going to be dealing with these transformations of space, which are going to be described with systems of equations. And the most basic system of equation are system of linear equations. So a linear equation is any equation with the form of like a1 times x1 plus a2 times x2 plus a3 times, and so on and so forth. How many variables there are is up to the system, is up to the equation, but it's in this form where none of the variables are raised to any sort of power, or you're not taking a natural log or like a cosine x. And the most basic sort of linear equations are always in the form of like x and y's, right? So this x2 really just represents a second variable. It could be a y. This x3 could be a z. And in 2D, this sort of linear equation, right, we have x and a y equaling a constant. That's a line. If you had a third variable, that's a plane. So let's say we have a system. Let's say we have a linear equation. X1 plus 2x2 equals 4. And once again, just to reiterate, these x1 and x2, they just represent like what the different variables. So this x1 could be an x, right? This could be 2y equal to 4, and equal to b some constant. I forgot to mention that. So let's say I want to solve this, so this is equivalent to this, right? Just want to reiterate that. If you want to solve this linear equation, you can already imagine that, hey, there are kind of like a bunch of answers to this. If let's say x2 is equal to 1, well then x1 would need to be 2, right? If x2 is 1/2, then x1 is 3. I can kind of, if I choose a number for x2, I can kind of figure out what x1 is, such that when I do x1 plus 2 times x2, I get 4. And now you kind of see why most people use x's and y's. Saying all the x1s and x2s is kind of crazy. But yeah, so let's say, there's so many infinite equations, so one variable is kind of like free. Like I can kind of choose any number for x2, and I can figure out what x1 is based off my choice for x2. So let's say the way you kind of solve this kind of parametrically, I guess, as the book says, is you say, hey, x2 can be any number s, right? Any number I choose. Then what is x1 going to have to be? Well, then if I have x1 plus 2s equals 4, well, x1 is going to equal 4 minus 2s, right? So if I say s is equal to, let's say, 3, then 2 times 3 is 6. 4 minus 6 is negative 2. I can figure out the other number. So x2 is like the free variable, and then x1 kind of depends on s. And then we can just bound to say s is in the set of all real numbers. A system of linear equations is really just, if you have a linear equation, right, with a certain amount of variables, whether it be 3 variables or 4 or 10, the next linear equation is going to have those same 10 variables, and you can when you have a different equation, it'll maybe equal to a different constant, and then you're going to have another equation, right? So if you think about a very simple system of linear equations, 2x plus 3y equals 1, and then 5x plus 2y equals negative 3, right? There are going to be these points. I'm not really sure exactly, and this is all kind of algebra review, but there are going to be these points that, hey, they intersect, and this point right here is common among this equation and that equation, right? There's a set of points that satisfy both of these equations, and usually you want to try to figure that out by solving the system. What is that point satisfying both equations? So in algebra class, you may have learned 2 methods. Substitution, which is more intuitive, I think. I mean, to me, you kind of isolate x, so you can say x is going to be 1 minus 3y over 2. Maybe you saw that substitution there. And then substitute it back in here and solve for y, for example. Like, it's a little nasty because there's a lot of fractions. So a better way to do it is by doing elimination. So the way you kind of do elimination is you can say, okay, well, if I have 2x plus 3y, and I multiply both sides by 2, I'm not changing the equation, right? I'm just multiplying both sides by 2. The equation doesn't change. And now, let's say well, the next, if I do 5x plus 2y equals negative 3, well, my goal is I want to eliminate a variable. I want to kind of eliminate a variable when I combine them. So if I multiply this side by 2, I will get 6y, right? I'll get 4x plus 6y equals 2. Well, what I see is I have like the 6y over here, right? And I chose 2 very carefully because if I now multiply the bottom by negative 3, right? 2 times 3 is 6, negative 3 times 2 is negative 6. So when I combine the equations, right, I'll get rid of a variable. So if I were to combine, I forgot the notation, I think it's like this or something like that, right? 4x plus 6y equals 2. So 4x, now negative 3 times 5 is negative 15. So 4x, right? So 4x minus 15x is going to be negative 11x. That's what I mean by combine. I'm literally sort of combining them. And what you're here, and I'll do the next part. So then I'm going to have plus 6y equals 2. Let me just finish this. Minus 6y equals, so negative 3 times, I also have to do it here. Negative 3 is going to be 9. Oh, positive 9, yes. Yes, positive 9, that makes sense. What you're really doing when you're doing this is, when you're doing this combining thing, so 6y minus 6y is 0, 2 plus 9 is 11, so I get x equals negative 1. I just want to make sure that's right, because I don't think that's what I got earlier. Oh yeah, it is. Okay, so when I'm doing this process, what I'm literally doing is I'm saying, well, when I'm combining this, if I did 4x plus 6y plus this minus 15x minus 6y, it will, when I add these all onto one side, that will be the same as adding everything on the left-hand side together, 2 plus 9. So, this, I'm not doing anything magical by doing this sort of, oh, let me add them together, combine and combine and combine. Really, it's just another way to package this all into kind of this cleaner step of combining, right? So once I get x is equal to negative 1, I can kind of substitute it, let's say right here, right? So I could say, well, now 2 times negative 1 plus 3y equals 1. That gives me negative 2. Add that over, I get 3y equals 3, and I get y equals 1. So that's how you kind of solve a system of equations, right? So this system of equation, this is what we call consistent. This is a consistent system because it has a solution. Some systems of equations, you might have come across them, have no solution. So let's think of the case. Wow, okay. Think of the case if you had, instead of 2x plus 3y equals 1, let's say we had 6x plus 9y equals negative 4. Well, what you notice is, you could say 2x plus 3y equals 1, and then you could also say, well, this is the same thing as factoring, like if you were to take a look at this side, if you factor out a 3 from the right-hand side, you get 2x, 3 times 2x plus 3y, right? So I get 3, and I have this factored out, 2x plus 3y. That's how I arrived at the initial equation. And if I say, well, 2x plus 3y I know is equal to 1, if I substitute that back in, I get 3 times 1 equals negative 4. Well, we know that's not true. This is not a true statement. So there is really no value of x's and y's that could result in, if you were to do 2 times that, 2 times x plus 3 times y equals 1, like there's no numbers, there's no 2 numbers that you could just multiply regularly and then get 2 different sort of outputs, if that makes sense, right? Like, this is really the same thing after I do the factoring. This is the same thing as 2x plus 3y equals negative 4/3. Well, yeah, there's no 2 numbers that if you were to do this sort of, I don't know, I don't really know transformations that well because I haven't gotten that far. But like if you were to do this sort of like, I guess, transformation and, if I were to plug in x and y, there's no way this sort of 2x plus 3y could get me 2 different numbers. That kind of makes sense. Okay. It's kind of long-winded. I know this is pretty rudimentary, but Now, the last sort of topic is more about systems of equations. Let's say you had something like this. So let's say we had a system of equations of 3 variables. All right. So 3 variable system of equations. Let's say we had something like, and then I'm just going to use the notes here. So x minus 2y plus 3z equals 9. Negative x plus 3y equals 4, negative 4. And then 2x minus 5y plus 5z is going to equal 17. So we wanted to kind of solve this system, all right? There's actually a really nice method to do this, and it's called rewriting this system in row echelon form. So if I have a system, I can really, I can do some operations that will result in the same system. So what do I mean by this? Well, one thing I can do is I could add a so one thing I could do is like multiply the system by like 5. So every single term I'm multiplying by 5. 5. So 5x minus 10y plus 15z equals 45. I think. Negative 5x, you can multiply everything by a constant and boom, you still have the same system. You just scaled everything up, but everything got scaled up, so the solutions are still the same. You could add a multiple of an equation to another equation. So, if you, this I need to understand a little bit more, but my guess is if you could factor, let's say this equation, you could factor out a 3, then I believe you may be able to multiply by 1/3. I don't know. I need to think about that one more. And you could also interchange two equations. So you could keep a system of equations basically the same, using just being careful about the operations. So if you want to rewrite this system, this is called Gaussian elimination. I'm going to kind of just walk you through it, and then hopefully this will kind of make more sense how it works. So let's say what you're obviously can probably tell by this system is that there are going to be some things that you could kind of easily eliminate. So in the first equation, I want it to be have all my x's and y's. In the next equation, I want it to have just y's and z's, or I guess you could have it just x's and z's, but in this case, you'll see that it'll just be y's and z's. And in the final equation, it'll be just in terms of z. That's what we mean by row echelon. Each equation kind of reduces a variable as you go. So we want to kind of get rid of variables as we go. So we have this first equation. Well, we want to get rid of the x's in the next two. So what we're going to do is we're going to figure out ways that we can get rid of the x's while still maintaining the system. So one option in this case, I think you can kind of see is, well, I could just add this equation to that equation, right? Because when I do x plus x, I'm going to get 0, right? When I do negative 2y, was this negative x? That was negative x, right? Okay. When I do negative 2y plus 3y, I get y, okay? And when I add 3z to nothing, I get 3z. And when I add 9 to negative 4, I'm going to get 5. 9 minus 4 equals 5. So I didn't change the system really, right? This, whatever point satisfied this equation and this equation will still have to satisfy this equation, right? So nothing really got changed. Now, let's take a look at, how do I get rid of the x's here? So to get rid of the x's here, what I'm going to need to do is I'm going to have to multiply, I have to do this equation times negative 2 added into here. So I'm just going to write the coefficients just to help me out. So I'm going to have negative 2. When I multiply this by negative 2, I'm going to have positive 4. I'm going to have negative 6. And I'm going to have negative, I think, 18. Let's start combining. So negative 2, that's obviously going to get rid of. That's why we multiply by negative 2, so we can have that sort of, negative 2 plus 2 equals 0, so we can get rid of that x term. So 4y minus 5y is going to equal negative y. Negative 6z minus 5z is going to equal negative z. And negative 18 plus 17 equals negative 1. Okay. So now let's do the next sort of step, which is getting rid of the y from this equation, which I think you will probably be able to see is really easy. You just gotta multiply by negative 1. So you can have negative 1, you could have negative 3 here, and you'll have negative 5. So when I do negative 1y plus 1y, that gets rid of that. Negative 3z plus 4z is going to be, negative 4z. Sorry, negative 3z minus 1z is negative 4z. Negative 5 minus 1 is negative 6. Did I even do this right? I think I messed up somewhere. Where did I mess up? Oh, that sounded annoying. Let's see where I messed up. I must have messed up somewhere. I think if you go back to 2x minus 5y, 2x minus 5y plus 5z equals 17. Let's just do the getting rid of this x again. So if we had negative 2, 4, negative 3. Oh, I must have, no, negative 6. I think I did do that. And then times 2, negative 18. So everything multiplied by negative 2. I get rid of the 2x. I get rid of the, so then 4 plus negative 5y is negative y. Then I get negative z. I do negative 6z plus 5z. And then negative 18, okay, this becomes negative 1. Oh, okay. So then I didn't need to multiply by negative 1. Okay, there we go. This makes more sense. So then this just, when we combine this, we can just combine pretty cleanly. So I get, that goes away. 3z minus z is going to equal 2z. And then this was negative 1, right? So 5 minus 1 is 4. So you could see I get 2z equals 4. Or, right, if I get 4, or this is just z equals 2. So now this is in row echelon form. This is pretty clean, right? Like, this is a really clean way to solve this system. Because I have z equals 2. I can go here, and then I can figure out y, and then I can go figure out x. It's pretty nice, actually. So this is a nice way to just be able to solve a system. Using that step of where you're kind of eliminating a variable as you go. So let's do another example really quickly from the notes. So if we have, let's say we had, let's do this in the annoying x1, x2 notation. So x1 minus 3x2 plus x3 equals 1. 2x1 minus x2 minus 2x3 equals 2. x1 plus 2x2 minus 3x3 equals negative 1. So let's solve this using this row echelon form. So basically, I want to get rid of the x1s in these bottom two. So what I'm going to do is I'm going to be like, hey, let's multiply this first equation by negative 2, because when I'm going to have that negative 2x1, when I combine it with 2x1, that variable gets eliminated. So I'm going to just write the coefficients, negative 2, so 6, when I multiply this, negative 2, and then I get negative 2. So this is going to go away when I combine. I'm going to have 6 minus x2, which is going to be 6x2 minus x2, which is 5x2. And I'm going to have negative 2x3 minus 2x3, which is going to be 4x3. So that's pretty clean. And then negative 2 minus 2 is going to be 0. All right. So let's do the next form. Or form. I don't know why I said form. Let's do the third equation now. Get rid of that x1. So what we're going to do is we're going to say, hey, well, this x1, I got to get rid of that. So I got to multiply all of these. I'll multiply the first equation by 1, so I got that negative x1, which will cleanly eliminate. So negative 1 for the first coefficient, I'm going to get 3. I'm going to get negative 1. I'm going to get negative 1. And then here, that's going to get rid of that. 3 plus 2 is going to give us 5. Negative 1 minus 3 is going to get us negative 4. And I am like kind of skipping and, I'm saying negative 1, negative 4. Remember, I'm always doing negative x3 minus 3x3, right? I'm just saying negative 1 minus 3. Just make sure you know what's going on, I guess. And then negative 1 minus 1 gives us negative 2. And I think you're going to see an issue. Because what's going to happen is, well, let's try to get, I think you're going to see it. Let's get rid of the x2 here right now so we can get an equation just x3's. Well, shoot, let's just multiply all these, the second equation, all the coefficients by negative 1. So I'm going to get negative 5. You're already here. I'm going to get negative 5. I'm going to get 4. I'm going to get 0. So now I'm going to get, that gets rid of that, but now I get 4 minus 4. So that reduces to 0. And now I get negative 2 plus 0 equals negative 2. This is my row echelon form, but you can see I have this 0 equals negative 2. There's no solution to this system of equations. This is what we call inconsistent. So hopefully this video was helpful in starting, I guess our linear algebra journey, because I'm low-key, learning all this too. And yeah, thank you for watching.